Okay, hello everyone. So this video I want to introduce electrical system again. And today class we will cover the what is daylight and what is suitable design in building. So first one, what is a good lighting? Good lighting, the definition that's good lighting will create a visual environment that enables people to see, to move, and to perform visual tasks efficiently and safely without causing undue visual fatigue and discomfort. So we have to consider we can get the comfortable in the indoor environment and also that's suitable energy use. So why the lighting energy is very important in building? So in residential and commercial building, 20 to 50% of total energy consumed is due to lighting. And lighting accounts for 20% of all electrical energy use, and lighting accounts for about 5 to 10% of total energy use. So that's why we want to research how to reduce lighting energy use in building. So here I list two approaches to get the sustainable lighting. First one, energy conservation and energy efficiency. So we have to consider how to reduce lighting energy use and then how to use high effective lighting fixture. So it can be described as minimizing energy consumption and carbon emissions while still maintain suitable illumination on an economically satisfactory basis. So that's about sustainable lighting. So as a designer, so how to design the day lighting received for your building or in architecture. So using natural light to illuminate building spaces and placing windows and other openings and reflective surface so that during the day natural light provides effective internal lighting. So we try to use suitable daylight to get the illuminate for our building space. And also if natural light is too high, this like direct sunlight may is discomfort. So how to consider the design about like indoor layout to reduce discomfortable direct sunlight and also how to receive more comfortable natural light. So I will introduce this later. And now, what's the benefits of natural light? Reduce energy consumption, provide high quality lighting, and increase business productivities. So that's why we need natural light for our building. So when we consider the benefits of daylight, so here have the three main sources from daylight. First one, direct sunlight, and skylight and reflected light. So direct sunlight actually for the building, this unexpected sunlight. I will introduce why it's unexpected. But skylight and reflected light usually is mostly used for the illuminate in building space. And daylight factor. So daylight factor is a ratio expressed as a percentage of the illumination outdoors to indoors on an overcast day. So typically, here is some type of space and the corresponding daylight factor. So at the actor studio and gallery, we need a high daylight factor. But for like living room, corridors, bedroom, and also bathroom, we need lower daylight factor, especially like restroom and bathroom. We can put them interior area, and we don't need to consider daylight for them. But for the like office, gallery, we have to consider how to get natural light for the building space. And we already said we need daylight, we need natural light. So some factors we need to consider when we design daylight for our building. So here is example sky cover. So some like California, Texas, Arizona, usually they have the clear sky, so less than 50% sky cover. So that means they can get the more illumination for their building space. But for the north of the U.S., they have the more than 70% sky cover. So that means if we want to get the more natural light, we need to consider the larger opening or larger window to get enough natural light. So this is one of the factors when we design daylight for building. So other design factors we also need to consider like location, climate, building form, building orientation, layout of interior elements, and the building materials. So location and location and climate, that's easy to understand. For example, the sky cover is related to the location, and also the weather is very important. For example, like southern Mississippi, usually we have the long warm weather. So during the warm weather, we hope the daylight is not too much, because daylight that's also mean we get much heat again during warm weather. It's unexpected. But for the some location, they have the long cold season. That means they need to get more heat again and less heat loss during the cooler weather. So we have to consider weather and location, and also building form, orientation, layout of the interior area, and materials we also need to consider to design our building. This related to daylight. So I will introduce what this. So first one, orientation. Orientation is very important because when we consider like our room facing and our house orientation, this related to the energy use. So what mean that? So in US, the best orientation is north source. The quantity of light is low, but the quality of sunlight passing through a space is high. So what's mean of that? So like right here, whatever summer or winter, we not too much, no or little direct sunlight in the source area. Say most in summer, the sun moving follow this line. During winter is this line. So not too much direct sunlight, because direct sunlight may cause glare, this discomfort sunlight for us. But if we put like in west area, so what happens in west area? In the afternoon or after 4 p.m. to 7 p.m., usually we will directly get the direct sunlight. So it may cause low quality of sunlight or direct sunlight. So the orientation north and south has a little problem with glare from direct sunlight, and openings do not require solar control device. So we can put like for the North of American, or they have the long cold season, they need more windows opening facing source, so that they can get good quality sunlight passing through a space, and also the quantity of light that's low, or quantity of direct sunlight is low. So just need to remember best orientation is north source. And building size, that's another factor we need to consider. So for the small building, we like here is small building, we have the window right here, we can get the sunlight for the most area. But if for the large building, we only have the window in the side, so we cannot make sure the full area we can get the sunlight. Like this area, we may need we may need digital or artificial light for this area. So how to adjust it? May need to consider additional interior configuration, or we can have some window right here. We can get lighting in this area, and also we can have the top light. So we can get the natural light in this area. So there's a method to adjust it. So here is example what is side light. So in multi-story building, daylight is mostly provided through window in the exterior wall. So in this area, there's a window, we can get light this area. If it's too long, like if the length is too long, so how to adjust it? We can place here have the window, and we have the window in both sides to receive enough natural light. Or other method, this top light. So daylight is provided by skylights, which is called top light. So we can place a horizontal, vertical, slope, or top area, horizontal, to receive enough natural light from skylight. And for the bathroom and storage, usually we don't need to consider natural light because only little time we need lighting. So bathroom storage can be located toward the interior or grouped on the east-west orientation with little or no windows. So when we design the layout of the room or building, we can design it like this area. Office may face have the window, and we can create the bathroom, design bathroom or storage grouped on this area, interior area. Okay. And we already introduced the benefits of the daylight. So what's the problem caused by daylight? The glare. So this one I introduced this usually from direct sunlight. So disability glare, light reflects off of the target or otherwise masks or reduces contrast of the target, disabling the visual task, like window reflected from computer screen. So we directly got the direct sunlight to our book, we cannot to see clear. It's a disability glare. And discomfort glare. Light usually from the side is brighter than that of the visual task enters eye and causes visual discomfort. So you sit close to the window, and then like during the noon or afternoon, like at 1 or 2 p.m., usually we got the very bright light on our computer or computer screen or the book. So usually it's discomfortable. So we have to consider how to avoid glare. So here is a solution. We can use a solar shading device. So block solar gain before it reaches the window. We can consider like horizontal or vertical shading device. Horizontal devices are most effective for southern or orientation, and vertical devices are most effective for eastern or western orientation. Okay, there's two types of the solar shading device, horizontal and vertical. So solar shading device, usually first one, we can avoid glare, and also we can reduce solar heat gain. Okay, and reduce heat radiation or reflection. So sometimes we need to reduce solar heat gain, like during summer. We don't want it, but during the winter, we hope we can get the more heat gain and reduce heat loss. So that means the different weather, we need to consider the different solar shading size. So how to adjust it? So now here is example. That one is vertical. It's vertical solar shading, and that one that is winner for the solar shading device design. So why? This one is automatical. It's automatically control shading device. Like during winter, they can have the more little or small shading. During the during the winter, they can get the larger shading. During winter, they get the smaller shading. So they can automatically control the size and also orientation based on the different weather, different location. And here is a solar skylight shading. This is a horizontal one or slope one. So during the summer or at the noon, they can close, they can put the larger shading, and during the winter or during the night, they can lift the shading. And the same as the interior solar shading for the apartment or house, they can lift the shading during the winter, and during summer, they can put down the shading. And daylighting and energy conservation. So interior heat load includes lighting and equipment from inside the building. Therefore, daylighting can eliminate lighting as an added heat load and reduce air conditioning needed to cool the building during summer. So when we consider daylighting, we not only consider the glare and the natural light received, we also need to consider thermal energy for the building. Like during the summer, we will use we hope we got the less heat gain in the building, so we may use some shading to avoid too much direct daylight going inside, and also we can reduce air condition needed to cool. So how to control it? Usually I list two examples. We can use automated building or automatic solar shading device. So automated building has a light seasons installed, and at the day lighting fade, artificial lightings turn on. And for the automatic solar shading device, exterior vertical shading device rotate with the sun. Interior shading device could be drawn as a light intensifies. So this we use automatic control to monitor the daylight. And the other one is energy efficiency in building. So I think we try to reduce lighting energy use. So why? So based on the two figures, we can find the building operation and building construction materials spend too much energy use. And for the building operation, the HVAC system and lighting spend too much energy use. So if we can reduce energy use in the HVAC and lighting, we can reduce the building operation and the energy consumption. So here is 4 factors we need to consider to design energy efficiency buildings. Like first one, orientation. If we design the building in the long cool season, we have to consider this is north source orientation, so that we can get the good quality lighting and less direct sunlight. And also design and passive strategies, we can consider use automatic control shading system. And also when you design the building, you need to consider location. There's a north area, south area, is warm weather or cold weather. And for new renewable energy source use, so we can use some solar, wind, renewable energy sources for to provide the energy for the building. So here is an example commercial building, large commercial building for the sustainable design. So here first one, they design the they design the building to reduce the building loads for HVAC system. So try to create or design high performance insulation, high performance windows, and also reduce infiltration, reduce outdoor air volume, reduce summer solar heat gain, but increase solar heat gain during heat season, and fault detection. Also, we can say it's automatically monitor or detect detection in the building. So, for example, what is high performance insulation? They use vacuum insulation panels. So this insulation panels can provide the high thermal performance, high thermal insulation. That means during summer and winter they didn't get the heat gain or heat loss between the indoor and outdoor. And the electrochromic window. So switchable coating between high and low light transmission, and manage glare, control integration with HVAC and lighting control. Best approaches varies with climate. So use this window, they can automatically control the high or low daylight they want to receive, and also avoid discomfort and disability glare in this building, and also have the automatically control with HVAC and lighting. They can reduce the energy consumption in HVAC and lighting. And this one, automated shading. So again, the automatical adjust the blinds to manage glare, indoor lighting levels, and solar heat gains. So that's very popular design, sustainable design in commercial buildings. And that's one that's demand controlled ventilation. So they can place the install sensors to control what is CO2 levels in this building, and then based on the level, they can adjust how much outdoor air they need or fresh air they need input in the building. And the last section in this class is about the renewable power source. So here I list the 5 top renewable power source: wind, hydropower, solar, biomass, geothermal. So this for PV panel. They can get the energy from solar, from the sun. So we can place the PV panel on the flat or slope roof in this area, and also this area. They can get the sunlight all the day or in the daily, and then to use it for like lighting, HVAC, and also equipment energy use. So here I list some information about the solar PV panel. So PV panels can be used to supplement normal utility power. It produces clean power and reduce energy consumption. And panels are typically placed on flat surface or sloped roof. They can be placed on overhang, which also acts as shading device. So that's one that's a very useful, sustainable design, because shading device is very useful in the warm season, warm location. If we can use PV panel as overhang and also as shading device, we can reduce heat gain during summer, and also we can get renewable energy from the PV panel. And they are placed facing the source to optimize the sun exposure. So again, that's why we need the source orientation. And they can be fixed or movable to change with the seasons, or even to change throughout the day to follow the sun path. And if the PV panels produces more power than the building need, it can be placed in batteries, or more common to feed the excess power back into the utility called net metering, which will give the customer's building offset or payback. So usually we encourage encourage customers or the people to use a PV panel installed on their residential building. They can put on the roof. This building, they can put roof area or on the flat ground. So here is the wind. They can get the mechanical energy based on the moving and then transfer to electrical. This one is a source of the biomass, so we can get the renewable energy from the agriculture, from animal residues, from the industrial residues. So this one is biomass. And I just give the example for the solar, for wind, and biomass. And this week homework is about the sustainability research assignment. So 5 popular renewable energy source: solar, wind, hydroelectrical, electric, geothermal, biomass. So you can choose one of them to do research. Your paper should include 5 sections. The first one, introduction to the closing renewable energy source. So what is your choosing renewable energy source and how is it defined? You also need to explain why this energy source is considered renewable. Okay, and the second one is advantage or benefit. So what is the benefits of the source and why we need to use it? And applications and real-world examples in building provide examples of the projects where this energy source has been successfully implemented and how is this renewable energy source applied in these projects. And the first one is challenges. So we already know the benefits of the source. So any challenges we need to consider, like economic challenges. So you can try to find any disadvantages of this source. And the current condition, which countries are using this renewable energy source, how much energy reduction or sustainability impact has been achieved through the adoption of this energy source. So you can find some data to validate the current condition using this renewable source. So this is about the homework. The deadline is next Thursday. You have 1 week to finish it. So don't use ChatGPT to generate the all writing because I want to know what's your new idea about the new renewable energy source. You can use ChatGPT to polish your writing and then to find some data, but don't let it to generate your writing. And no attendance assignment for online students. You only need to complete research assignment by due date this week.